Alright, let's take a look at section 1.3, which happens to be using midpoint and distance formula. We have two main terms that we're going to look at right here. The first one being midpoint. And for those of you that are using Kami, went ahead and just highlighted our definition. If you're not, make sure you guys write it down. The midpoint of a segment is the point that divides the segment into two congruent segments. Once again, if you recall, we talked about segments that are congruent. And how do if I just look at this diagram, I know that AM right here happens to be congruent to BM. The reason being is because we have the little hash mark in between. So by knowing that these two segments are congruent, then that tells me that point M happens to be in the middle, or what we call the midpoint. So M is the midpoint of segment AB, and then it says segment AM is congruent to segment MB. And then remember, if two segments are congruent, then we can safely say that those two segments are also equal. But remember, we typically use equal when we have actual numbers or values. We go down right here, we'll take a look at a segment bisector. Now, a segment bisector, it could be the following: a point, a ray, a line segment, or a plane that intersects the segment at its midpoint. So I could have, for example, like this line right here. If I say that this device is, or this pen right here is my line, and the marker could be a segment bisector. Okay, it could go diagonally, vertically, any which way. As long as it's going through the center of the line, then it would be considered a segment bisector. It could be a ray, so if I set it up like this, that would be considered a ray. If I take a piece of paper, that could be the plane. So for example, right here, if I take this piece of paper and I go through, then that could be the plane that is being the segment, or the segment bisector. Okay. And once again, it is cutting the segment in half and creating two equal segments. Next up, as we come to the midpoint formula, the midpoint formula we will use when we're given 2 points and we want to find exactly where is the middle. So we have this equation right here, x sub 2 plus x sub 1 divided by 2 is equal to y sub 1 plus y, or sorry, not equal to, but the y coordinate will be y1 plus y2 divided by 2. So remember, these two right here solves for the midpoint. The midpoint of x we have right here, and this is the midpoint of y. It's important for you to memorize this because you can't always just say, oh, let me take a ruler and try to measure things out. So to be able to get that exact calculation, you've got to use this midpoint formula. Now, the reason why I put midpoint x, midpoint y is because later on, the most challenging problems from this section is not finding the midpoint, but it's understanding, they're going to ask you to find one of the endpoints, and understanding that based off of x plus x sub 1 plus x sub 2 divided by 2, that actually gets you the x coordinate of the midpoint. And the same thing for the y coordinate with y1 plus y2. As we continue along, we have our distance formula. That's something that I already showed you already. but we use it right here to find the length between 2 points. Okay, and then make sure you go ahead and memorize that as well. When we have the length of 2 points, we take the square root of x sub 2 minus x sub 1 quantity squared plus y2 minus y1 quantity squared right there. All right. And if you're wondering where is this equation derived from, they kind of show you how it is derived from understand the concept of the triangle and thinking about the Pythagorean theorem. But we'll save that for another day as far as the details are concerned. So let's go ahead, move along, and get to our extra practice. Okay, don't forget that in your notes, guys, make sure you have the extra practice written down. Okay, that you just don't have your notes, vocabulary terms, but also include your practice questions that we're going over with together. All right, so remember, let's try to set things up whenever we can. Number one, they ask for 2 things. So remember, there are some questions that do ask you for multiple parts to your problem, and this is one of them. If all you do is answer one part, then you're only going to get half of it correct. So it says, identify the segment bisector of segment AB. Now look right here, in between, that happens to be a point. So that would be that segment bisector. I can go ahead and put point M. Okay, then it says find what is AB. Well, if this is a segment bisector, and I know AM is 13, BM is 13 as well, so AB is equal to 26, adding the 2 together. On number 2 right here, I can see that they may not have a point right here at M, but I know that from A to M is congruent to B to M. And so right here we have ourselves a ray, and so we will call this ray MC. Don't forget to draw it correctly, or make sure you label it correctly. And A to M, or sorry, A to B is equal to 16. For number 3 right here, we see that AM is once again congruent to BM, and then this time we have line L that bisects our segment, and segment AB is going to be 26 times 2, which happens to be 52, or 26 plus 26. All right, let's move on to the next question right here. We'll take a look at number 4. And so they're saying that identify the segment bisector of segment EF, then find EF. So it looks like there's going to be some equations you're going to need to make. The segment bisector of E to F right there. This happens to be another ray. So we got ray MT. Okay, there's our segment bisector. And in order for us to find E to F, okay, think about your segment addition postulate. Now, sometimes we may take the 2 different parts and set them, add them up to get the whole entire thing. The problem with this right here is that I don't know what EM and FM are. So, but what I do know is that they are congruent segments, meaning that they are equal. So what I could do right here is I could take EM and set that equal to FM because they are congruent. So let's go ahead and substitute things in, and I've got 6x is equal to 2x plus 4. And then you go ahead and solve it out. Okay, so then when you solve it, well, we go ahead and subtract 2x to both sides. And I have 4x is equal to 4. Divide both sides by 4, and x is equal to 1. Okay. So what I actually did was find x. I'm not done because we need to find E to F. So in order to find E to F, we go ahead and plug this stuff in, and I could go ahead and plug in right here. We know that e to m right here, if I take 6 times 1 right here is 6. And then I could plug it in over here as well. We got 2 times 1 plus 4, and all together combine that up. That is going to get us 12. So e to f right here is equal to 12. You can show your work by plugging in. They're showing like 6 times 1 plus 2 times 1 plus 4. Okay. So when we have ourselves our segment bisectors, we can go ahead and set the two congruent parts together. Easy as pie. Let's go ahead and take a look at number 7. These questions are saying the endpoints of segment PQ are given. My computer is on the fritz. Keeps messing, keeps scrolling around randomly. Hopefully that won't be a problem next time. So once again, we are taking a look at number 7, as long as it stays in one place. Gotta love it. Gotta love technology. All right, moving down. Once again, number 7 says the endpoints of segment PQ are given, and you want to find the endpoint or the midpoint, which is M. All right. So a lot of times, what I like to do is just go ahead and we label our points. So remember, we'll go ahead and say that point P is point 1. So I'll label -4 as x1 and 3 as y1. And then Q, we'll go ahead and put the points as x sub 2 and y sub 2. So it's easier for us to go ahead when we use the equation, just plug things into where pieces belong. Now remember, our equation is x sub 2 plus y, x sub 1 divided by 2, and then we have ourselves y2 minus y1 divided by 2. So we just go ahead, we'll plug the numbers into our equation where they belong. We'll start off, I got -4 plus 0 divided by 2, and then for y, actually sorry, if I were to go back and use the numbers in the correct spots, we can go ahead and get 0 plus -4 divided by 2, and then we have 5 plus 3 divided by 2. Now, it doesn't matter realistically which numbers you use, or like, as you can see, I substituted x1 in for x2. As long as you are consistent with the numbers, either way works out, okay? But because I already labeled these, might as well put everything together correctly. And I've got 0 plus -4 is -4. Divide that by 2, and we're left with -2. 5 plus 3 is 8, divided by 2, and that's 4. And so our midterm, or midpoint, right here is at -2 and 4. You don't even have to draw things out, and you can get the answer. All right, and that's the whole beauty of this. So midpoint formula, you've used that already, so we don't have to go in too much detail about that. The hardest question in this section is going to come up right now. It says the midpoint M is one point of segment JK, okay? And then the midpoint of JK are given, or the endpoints are. So the difference here is this. If you think about it, they're telling us that, now this is not an exact diagram of what's going on, of the problem, but we have J to K. And what they're saying is that they gave us J. This is given. The midpoint is given. That's what we need to find, is K. So I can't just plug things into the equation and solve it out, because they gave us different parts. But if you recall, but we do use the equation. Let's go ahead and set it up right here. Now, for 7 and 2, I'll go ahead and label this as x1, y1. The biggest mistake that people use is say that this is x2 and y2. But you can't because it's not the same, it's not the endpoint. This right here I could put as like midpoint of 1, midpoint of 2. Or, so let's go ahead and see what we're going to do right here, how we'll put this together. Or I can go ahead right here, let's say this is x and this is y. Okay, not x1, y1, not x2, y2. So right here, let's go ahead. If I use the equation, it's going to be x sub 2 plus x sub 1. And so x sub 2, we do not know what it is. That's the unknown, right? That's part of point K. I'm going to go ahead and plug in 7 right here. We divide that by 2, because that's part of the equation, and usually we're finding this number. However, this time, we know what that x-coordinate of the midpoint is, and we plug in 1 right there. And then you go ahead, let's find what x sub 2 is. We will multiply both sides by 2 to get rid of that denominator, right? Cancels it out. I've got x sub 2 plus 7 is equal to 2. And then we'll go ahead and subtract 7 to both sides, and we're left with -5. And there is x sub 2. We will repeat this. We've got to find y sub 2. So we got y sub 2 plus 2. We're going to divide that by 2 right here, and then we set that equal to the y-coordinate of the midpoint, which is -2. All right. We'll go ahead and multiply both sides by 2 to once again get rid of our denominator right here. So let me create a little more space. We multiply both sides by 2. That cross cancels. We got y sub 2 plus 2 is equal to -4. And then subtract 2 to both sides, and we got -6. So what that's going to tell me right here is that our midpoint, or sorry, our endpoint happens to be at -5, -6. And that right there is our endpoint. And that would be point K. And there you have it. There you go, 1.3. Good luck with your homework.